All right, so welcome back from break. This marks basically the halfway point of the course in which we're going to turn our attention to data structures and algorithms. We're going to start with lists and list-based data structures, but we're also going to get into algorithms, algorithm analysis, as well as tree-based data structures, binary search trees, and heaps in the end, at the end. So with list-based data structures, we've already seen lists in action. You've used array lists, you've used maybe linked lists, maybe not. But now what we're going to do is we're going to start understanding how these data structures, these dynamic data structures, are designed and how they're implemented, because we're going to do our own. Right now, in practice, you would never actually do what we're about to do. Because you would use what's built into the library or whatever. But we do need to understand how these things work and when it is appropriate to use one or another. All right? And so that we do have to pay attention to the details. Our motivation for doing this is that we like dynamic data structures. Lists, sets, and maps are way better than just simple arrays, right? We've already seen that in practice. And of course, we're going to start leveraging every single one of those object-oriented programming principles that we've covered up to this point. We're going to use encapsulation, we're going to use abstraction, inheritance, and polymorphism, as well as everything that we've done with respect to testing as we're designing our own list-based data structure. As we've already seen, arrays are bad. They're bad in that you can go ahead and create an array in Java if you want. And a lot of people start out with Java with creating these static arrays. But there are a lot of problems with them, right? Once they're created, their size is fixed. They cannot be changed. What if I want to hold 11 elements in there instead? Or what if I only want to hold 5 elements in there? Right? Either I'm wasting space or I have too many things to put in there. If we wanted to actually keep track of that, we'd need to do a lot of bookkeeping ourselves, right? Which indices have been used? If we wanted to put 10 elements in there and then take out the middle element and throw it away, right? Then we have to say, well, that one in the middle, that's not being used. You can go ahead and put something there, right? That's not how arrays really work, right? We like our data contiguous. We like things right next to each other, right? What about if we wanted to delete or remove elements, right? Well, if we wanted to delete or remove elements, those would leave gaps, right? We've got 10 elements here, and I wanted to delete this one right here. We would have to shove everything over ourselves in order to make sure that there were no gaps, right? And the solution that we're going to go with is a dynamic data structure. A dynamic data structure automatically resizes itself. It either grows or shrinks as you add stuff or remove stuff, right? Based on whether or not you insert, add, or delete, all right? We won't have to worry about those details. There's abstraction and encapsulation at work. Right? We just have this list. I'm going to put stuff in or take stuff out. Right? I don't have to worry about, well, also, as it puts something in, it automatically grows to accommodate that new thing. I don't have to worry about that from the outside world because it's abstracted away. It's encapsulated inside the class and taken care of by the class itself. Let's think about some functionality, because that's where we're going to start. Functionality. Right? Remember the basics. CRUD, create, retrieve, update, and destroy. C is going to be create, right? We're going to want to be able to add things or insert things, right, etc. Right? We're going to want to be able to retrieve things, right? Oops. There we go. All right, we want to be able to retrieve things, right? We want to be able to get an element. Now, when I say an element, what do we mean by that? We're going to have to design that. Do you want the first element? Do you want the last element? Do you want the element that matches some certain criteria or something? And then the U, the update, right? We want to be able to remove and add an element, right? So that 5th element there, we want to replace that with 42, right? We could do that, and we could actually do that with the D, the delete, right? Along with the create or insert, right? So this is actually just two other operations put together, right? We want to be able to modify things, right? Or that's basically update, modify elements. All right, there we go. And then D, delete. We want to be able to remove elements, right? Okay. So all of the details are going to be encapsulated inside the class, or the inside the data structure. We're going to be designing this data structure, so we don't have to worry about it. We only want to use the data structure abstractly. We want to be able to call the methods on that data structure. Right? So with an array-based list, what we're going to do is we're going to go through a design of this. Right? In fact, here are the step-by-step process that we're going to follow here. We're going to design the interface first. In other words, the publicly facing methods. We don't mean Java interface in this case, but we could mean that if we wanted to. But in this case, an interface, what do we mean by an interface? The public methods, right? Not necessarily defining an interface. Again, we could if we wanted to. Then we're going to design the tests next. This is something called TDD, right? TDD equals test-driven development, right? And in fact, strictly speaking, we're not going to do TDT. We're going to go back and forth. But TDD says that you should design all of your tests before you do any of your implementation. Because how do you know if your implementation is correct unless you've got some tests to test it against? Well, we're going to take a little bit more nuanced approach and go back and forth. We're going to design a little bit, implement a little bit, test it, then go back and forth between those three steps. Then we're going to implement the interface, update our designs, tests, and implementations as we go along, because we might realize, okay, well, that initial design was good, but now we've got different, different requirement, and we need to restructure a couple of things, right? It's going that testing phase is going to inform our design phase, right? And we're going to have to go back and forth on this, okay? So let's come over here, and I've already set up a brand new package here called UNL SOC lists. We're going to use this demo class as an ad hoc tester so that we can create a list and then put stuff in it and test it. But we're also going to do some formal unit testing here as well to get more practice doing that. Okay. So let's go ahead and create a list, right? And I'm going to call it, I don't know, let's initially call it my integer array list. All right, there we go. We are not going to cheat, and we're not going to immediately jump to the array list based in in Java here. In fact, on your final assignment when you're doing your own list, you're not going to do that either, right? Otherwise, 0 points there. Instead, we're going to understand how it works by designing it from scratch, okay? So now what do we want in this? Well, first of all, it's going to hold integers. So if it's an array list, it's an array-based list. That means inside my class, I've got an integer array here, right? That I need to give a name to. So let's go ahead and get rid of that white space there. What should I call this? I'll just call this the array, or ARR for short, right? Okay. Now, I'm not going to get away from that, right? If this is an array-based list, I still have to have an array at some point in my design. And so there it is, okay? But I've made it private because I'm going to protect it. There's good encapsulation right there. Right? Now, what else should I put into this? What else should I put into this class? Well, we might have to come back to that then. So let's go ahead and just start designing the interface. Remember the CRUD. I need a way to put stuff in, I need a way to retrieve stuff, I need a way to delete stuff, etc., etc. Let's design at least a few of those methods, one for each, or maybe one for at least the three main ones there. And then we'll come back and then we'll design our tests, and then we'll come back and start implementing and realizing, oh, well, we also need this thing, or we also need that thing, okay? So give me a create, right? I need a way to add things or to insert things. Right? So let's do yeah, go ahead.
Well, before we do that, would we need to specify the size as a separate variable?
Oh, okay. Size of the list, right? Or the size. Well, we've got an array here, right? Doesn't length do that? We'll think about that and come back. All right, but I do want to put in a to-do here. To-do. Keep track of the size of the list? Question mark. All right. Let's design the interface first, though. Right? The publicly available methods. I need a way to get stuff into this list, first of all. So what kind of let's make it public, right? What should we call this method? Put stuff in, right? No. Add, right? Okay. All right, and we'll go ahead and add an integer, int x, right? And then we'll leave it blank here. Well, what's the return type going to be here? Void? Okay, I like that. Why? Because we're not returning anything. I'm the list. You're giving me an integer x, and I'm going to put it into the list. Where am I going to put it? We need to decide that, and that's why we write documentation first. Where is this going to add it? Is it going to add it so if I've got a list right now, it adds it at the beginning, or it adds it at a random location, or it adds it at the end? Which one of those makes the most sense? End? Okay. Adds the given element x to the end of this list. I like that a lot. Right? Note that I am not implementing it yet because I haven't written any tests to test to see if it works yet. All right, that's one crate. We might want a way to insert something later on, but we'll go ahead and deal with that later. What about a way to retrieve something? Right? So public. Right? What's the return type here? And what should I call it? Retrieve. Right? I before ye, except after c. I don't want to deal with that. Right? So what would be another one? Oh, another verb here. Get. Right? All right. Get what? Get x? What would be your interpretation of this? Right. So if there's 10, 20, 30 already in the list, and you wanted to get 20, okay, I'd go through the list, oh, there it is, right there, and give it back to you? Okay, I could do that. I could say gets the first instance of the given variable value x in the list, and returns it. Now, at least in this design, in this initial design where we're only dealing with integers, right? Does that really make all that much sense? Okay, you want 20? Okay, here you go, here's 20. You're the one that gave me 20 to begin with, right? Why do you need it, right? So let's go ahead and make, well, okay, I could say index of, right? So tell me what the index of the value 20, where is 20 in the list, right? We could do something like that, right? But I do, and we'll add that later on maybe, but I just still want get. Get what? Get the, so you do want to do index of. All right. I will return the index of the first element 20 that you ask for, right? Or do we want to do this one? Get what? All right, so get an index, right? Get the element at index. Get element at index. That's what I would call it if I were verbose, right? And so I'll say int index. Now let's update this, this documentation here. What should I return, by the way? An integer, because you've asked for the integer at that particular index. Returns the value stored at the given code index. There we go. Right, there. Okay. Now I'm going to return a 0 value here just so that it compiles, right? But we'll need to come back and do this, right? Because I'm going to put to-dos everywhere. Implement. To-do. Implement. Reminder to myself that I still need to do this. Okay. What about update? Well, that's just a remove and add. So we'll come back to that. What about delete? Remove an element at a particular index, or remove an element, the first index, first value of, right? Public delete element at index. There's one way that you could do it. What else could you do? You could delete the first instance of, right? And then if you gave me 20, I would look through 20 is the first instance of, I'll kick that out of the list, right? Which one of those do you want to do first? Delete element at index. That would certainly be, consistent with everything that we've done so far. Index-based operations, right? So we'll delete element at the index. There's no need to put it in the name. That's what documentation is for, and that is what parameterization is for here. If you look and see that there's a parameter here called index, it's a pretty good indication that it's an index-based delete method here. Right? So removes the element at the given index. All right, I like that so far, but we do need a return type here. What's your first inclination? Void? Okay. Could we use that for something though? What could we use it for? Boolean, it had an effect, right? Remember our design with insert person, right? It was a void function at first, and then we changed it into, well, we could use that, right? We could return an integer value of the newly inserted record's primary key value. And then we thought one better, well, wait, why do that? We could just return the entire object, right, with that set. What could I do here? What if I did an integer here? Removes and returns the element at the given index. You're free to ignore it, right? If you want to ignore that value, fine, and you just want to delete it, you don't have to capture it into a variable value. Right? So let me go ahead and grab this and put it down here. Right? There, to do implement. Now, before I do write one piece of code to implement any of these things, let's come over here and think about tests, test-driven development. Let's go ahead and create a class here for unit testing. And this will be my integer array list tests. All right, there we go. All right, and I will need a test here at some point. What I think it's public void test 01 is what I'll call it initially. Okay. I'll need to bring this in, and of course from the JUnits. Yeah, just JUnit right there. Okay. All right, so let's go ahead and test the first one there. Add an element at a particular index. Okay, so we'll need to of course create a my integer array list instance, right? Foo or the list is equal to new my integer array list. There we go. And then I'll say list.add 10. In fact, let's not just add one thing. Let's add 3 things: 10, 20, and 30. Okay. Now, what is your expectation after having done that? Remember, there is no implementation here at all. I only have an interface so far, the publicly available methods. But I can still design my tests around that, even without an implementation. Right? What is your expectation for the list at this point? Let's just note it in the comments here. What should it look like? 10, 20, and 30, right? This is what it should look like. Should look like. Right? How can we test to see if that's true or not? Right? Well, just by adding something, you can't, right? But guess what? We already designed the rest of the interface here as well. Get element and index. Right? In fact, I like get better there. Right? Let's go ahead and do that. Right? All right. So if I say list.get the element at the 0th index, what value should that be? That should be 10, right? So let's assert equals x and 10. That's our expectation. I forget which of the order is, but we need to import that anyway. Add static import for, I want assert, maybe it's assertions. Yeah, it's assertions. There we go. All right. And then let's read the documentation for it. It's expected, then actual. So I should actually go 10 and then x, right? And I should call this actual, right? Okay, there. And let's go ahead and put that into a variable. Int expected is equal to 10, right? And so we can put this right here. There we go, okay? Now, of course, it's going to fail right now because what does it return? Well, add doesn't do anything. Return returns 0, right? So it's going to fail here. And if I look at it, right, if I look at, let's go ahead and bring this over here so that we can see it. Right, there we go. And there it is, that the expected is 10, the expected is 10, the actual is 0. That's not 10 right there, that's the line number, right? Okay. So it's failing as expected because we haven't actually implemented anything. Should I only test one of these? Probably should test them all, right? So let me go ahead and put in int expected and actual as declarations up there so that when I do a copy paste here, reset, it should be 20 and 30, and those should be 1 and 3. If any, 2, right? If any of those should actually fail, then the entire test fails here, right? Now let's give this a more descriptive name. It's not just the first test, it's testing what? Test add and get, right? Because it's testing both of those things together. okay? And again, it's going to fail because we haven't actually implemented any of these things yet, okay? So now let's come over here, and we'll worry about delete later on here. We're going to go back and forth. We're not going to be doing pure TDD here. We're going to go back and forth as we go along, right? All right, so let's implement this function. Okay, actually, let's leave that until we've actually implemented it. Right? What's the first thing I should do here? How do I add it to this array right here? Array of something is equal to x, right? I want to add it to the last available slot, right? So now let's come back to your idea of, well, okay, now I actually need to keep track of the size of this. Not the size of the array here, but the size of the number of things that I put into that array, right? What initially is the size? Private, int size, okay? What value should I assign to size initially? How many things have I put into the list when I've created the list? 0, right? There are 0 things in this as of line 12. So we can initialize this to 0, right? And now where's the last available slot? If on an empty list. Here's an empty list. Where would you put it? At index 0, right? Now what if there were 2 things in there, 10 and 20 already? Then where would you put it? At what index? 2. Well, what was the size if you were keeping track of that? 2. I see a pattern here. Where are you going to put it? At size. All right. Okay. Now let's go ahead and try this. Let's run this. Remember that the expected was 10, 20, and 30. Does this work now? Right. No, it still fails. But it actually fails for a different reason here if you take a look at the details down here. Null pointer exception. This .arr is null. Right. Did we ever actually set it? Set ARR right here. Right? Nope. What does that look like when you're working with a regular old array? You have to actually initialize it. Okay? So where do I initialize that? Let's try it up here. Equals new int of, say, size 10. Right? Actually, we only need one thing in there, right? One thing. Okay? So now that null pointer exception is going to go away in my tests. Right? At least initially, right? But the original was 10, and now it's still 0 because we haven't implemented that get method yet. So let's go ahead and implement that get method, right? You're asking for something at a particular index. How are you going to deal with that? Return not 0, but return what? This dot array of the index, and that's it. So all our problems are solved. Let's come back over here and run this. Nope. So expected was 10, but the actual was 30. Okay. All right. So what else needs to be done in our add method here? Yeah, we never updated the size, did we? This dot size plus plus. Why? Because you just added this x right here, right? You can't just keep adding it to 0, 0, 0, 0, right? So we need to update this size here, and does that solve all of our problems? Let's find out now. Right, now we've got a hell of a lot more to do. Right? All right. Index 1 is out of bounds for length 1, right? And I can't double click on that and show you what it looks like, so you're just going to have to squint your eyes and take a look at it. What's going on there? We added this 10 here. Then we tried to add 20. How big was the array? 1. So when we have something of size 10, or of size 1, and there's like size is equal to 1 here, then where are we going to put that next thing? We're going to try to put it right here. But its size is what? Its capacity is 1, right? So I'm going to have to do something else here. Let's just bump that up to 10. Does that solve all of our problems? No. When we get to the 11th element, what happens? We're going to have the same array index out of bounds exception here. Okay? So we need to rethink of this, right? We need to say that if the array is full, then we need to expand it, ... Okay? So let's check for that first of all. If the array is full, then expand it. Okay? How do I determine if the array is full here?
Compare the length to the actual size.
Compare the length to the size, this dot size, right? And if the size, we put, it has a capacity here, this length here, and we put 10 things in there, that means it's full, okay? Then we need to expand it. Actually, before we go on, that sounds like it might be useful, right? We're probably going to use this multiple times. And if we're going to use this multiple times, should I go ahead and copy and paste this checking code here 5 times? Like at least half of you did when you had this round function. Now you just cut and pasted, cut and pasted, cut and pasted. Make a damn function, right? So that you don't have to cut and paste every single time. Let's go ahead and make a function to do this. Public is full, right? What's the return type here? I'm asking a yes or no question, so Boolean, right? And I'm not going to say, if this is true, then I'll return what? Return true. Otherwise, return false. Don't write code like that. If you've got a logical statement here that's true and you return true, and if it's false, you return false, just return the logical statement, right? Return this. Right? That'll return true if it's true. It'll return false if it's false. Right? Okay? So I'm going to go ahead and use this now up here. If this is full, right? Much more English-like, right? Okay? Now we do have to expand it. Maybe we want to put that into a function. We'll talk about that later, though. Right? How do I expand it? I need to create a new array, right? Int new array is equal to new int. How big should it be? Should it just be 20 now? Now, what if I added 10, 20? What if I added 20 elements? Now the 21st one will fail. So what should I do? The old one, right? arr.length plus some other factor, say 10, right? You could actually change that to be like twice as many, right? Or you can have some adaptive function there or something. We'll go ahead and keep it simple here and just simply add 10, right? Every time it fills up, we'll add in more capacity for 10 elements. You could, of course, just add 1, but now you're resizing on every single insert, and that is going to be extremely inefficient. We'll only resize this on every 10th insert, okay? All right, now that I've got something big enough, do I just say this dot array is equal to the new array? Or new array, there. What's in this new array as of this line 19? Zeros, right? In fact, what's wrong with you? Oh, I need to, there, correct syntax, right? What's in there? Just a bunch of zeros, because that's the default in Java, right? What do I need to do to make sure that I'm preserving all of the old ones, that 10, 20, 30, and et cetera, et cetera? What do I do to make sure that I preserve those? I need to copy over all of the elements from ARR to new ARR, ... Everybody here knows how to do that. For int I equals 0, I is less than arr.length, I++, it's just an idiomatic for loop here. The new array sub I is going to be equal to the old array, arr, this dot arr, dot of I. And best practice here, I should be saying this in front of all of it. There's only one arr, but I should be putting this in front of all of them for best practice, okay? And it's not new array, it's new arr. There we go. Right. And then I can say, okay, that old array, throw that away. We don't need to worry about that anymore. We're going to take that new array, and now that's our array. In another programming language like C++, you'd have to clean it up, right? You'd have to say, or C or C++ or something like that. You'd have to free the old array here, right? Before you do this. But of course, this is Java. We don't need to worry about that. It becomes eligible for garbage collection, and we don't have to worry about it anymore. Right? Wow, that seems like a lot. Do you think that there's a function to do that for? I mean, maybe we could put that into our own function, right? Just like we did is full down here. But what's the very first question you should ask yourself when approaching a problem? Is it already, does somebody already solve it for us, right? And the answer is yes. Arrays.copyOf has already done this for you. You can go ahead and have a copy of the new array, or the old array, this dot array, and it has a functionality here to take on this value, right? Let's go ahead and read it. Unfortunately, it's going to be very small. Copies the specified array, truncating or padding with zeros if necessary, so that the copy has the specified length. In other words, it's going to copy this array and return a new copy, right? This dot array. Oops. Arrays. Copy of. Right? In other words, it's going to copy over the entire other array and then pad it out with 10 new zeros so that its capacity is now increased. And you don't have to worry about that at all. Right? Much better code. Right? There. All right, let's see if this works now over here in my integer array tests. Let's run this. And of course, we're not testing it very well because we're only testing 3 things here. Right? So let's go ahead and create another test. Right? I'm going to copy this. And I'll say test bulk, add and get. Right? And what I'm going to do is I'm going to go into a for loop here instead. For int I equals 10, I is less than, let's go up to less than or equal to 100, I plus plus, or plus t, let's go by tens, right? Plus equals 10. So I'm going to insert 10, 20, 30, 40, all the way up to 100. Actually, let's go up to 1,000, right? Because it's all automated anyway, who cares, right? List.add I. Right? What should it look like at that point? 10, 20, 30, 40, dot, dot, dot. What should be the last element in there? 1,000. Right? It should look like that. So let's go ahead and create actual and expected, and let's go into another for loop. I'm going to go ahead and copy that because it's exactly the same thing. And we should expect that the ith element, actually no, let's go with a traditional for loop here. For, how many things are in there, by the way? 100, right? I plus plus. In fact, we should probably be testing that as well, right? Right? Test. Make sure the size of the array is 100, dot, dot, dot. In fact, we should have done that up here too, right? It should look like this. To do, test that this the array that the size of this is 3, right? Okay. We'll come back to that though, and so that's why I'm putting it into to do. Okay. So I'm going to go ahead and go through every element. Let's go ahead and get the actual is equal to list.get the ith element, right? And then we'll do our assertion here. What should be the expected, by the way? Expected is not 10 always. It's going to be, how do we do this? I times 10. I plus 1 times 10. That'll go 10, 20, 30, 40, 50, right? Right? Because it starts at 0. 0 plus 1 is 1. Times 10, right? Just basic simple math there, right? Assert equals there. So is this going to work now with 100 elements inserted into this? Let's find out. All green, 2 of 2 tests pass, right? Actually, I'm making 100 mini tests here, aren't I? Right? But I only had to write one actual test function to do it. Right? Look for tricks like that. You've got a lot of testing here for not a lot of code at all because you're doing this in a bunch of for loops. Right? Now, before we move on, let's go ahead and go back and do this test here. Right? Do you see any of the interface here that allows you to determine what the size is? Right? If I were to ask, is the size of the array 3? List.size is equal to 3? Right? Nope. So what should we do? Let's add that, right? Public int size, right? Return this dot size. Okay. All right. I like that. So let's go ahead and make sure that the size is 3 here. Actually, we could do it we could do it in 3 phases here. Assert equals the expected size after inserting one element is 1, and so list dot size. Right? If it's 1 after the first element, great. In fact, what we should do up front is yeah, we should do it up here, sorry. 1, 2, and 3. 2, and 3. And before all that, we should test an empty list. Right? Okay, I like that. In fact, I would probably start breaking these up into multiple different tests at this point, but you get the idea, right? Does all that work? Still green, right? Awesome. Should we do that down here? Well, I'll leave that as a to-do, and you can do that, because all you'd have to do is take this code up here and put it into your for loop here, for loop up here, okay? So I'll actually move that to-do up here, right? Okay. All right. Well, I'm convinced that these first two things that we've done work so far, so I'm going to go ahead and take that away, that to-do implement there, right? We can add stuff, we can retrieve stuff. Something's bothering me over here, though. We only asked for things that were expected to be there. Let's go ahead and add another test for things that should not be there. Public, void, test empty list, or test invalid, valid something. All right, well, I'll give it a better name once we've figured out what we're going to test. What if I were to create a list here, and I were to immediately, not put anything into it, but I were to immediately ask you for the fifth element, dot get, the element at the fourth, index 4, right? That's the fifth element right there. What would you expect it to be? So int expected is equal to something. Int actual is equal to the fifth element. Right? What would you expect it to be? 0? Okay. And let's go ahead and assert equals here. And let's see if it works. Come on, there we go. Okay, yeah. Passes the test. Does that make much sense, though? Should you be able to ask for the fourth element? What if I said the negative fourth element? Would your answer still be 0? Absolutely not. What should it be now? Yeah, that's way out of bounds, right? That should be an error condition, right? So what if I had asked you instead for 4,000, right? That's way out of bounds on the other end, right? And so here I'm getting a 4,000 out of bounds for length 10. Does that make much sense for an abstracted list? Right? What the hell is an index here, right? My integer array list, I just asked you for something, and you're giving me this array index out of bounds exception, right? I don't know what you're talking about, because the fact that there's an array under the hood here, I should not have to worry about that. Remember, those are called leaky abstractions. And this is a leaky abstraction here. We don't want that. All right. So how do we deal with that here? Let's do some basic error handling. If you ask for something invalid, I'm not going to let this throw this array index out of bounds exception. I'm going to throw my own exception. If out of bounds, right, we'll throw a new illegal argument exception. Right? Index equals plus index plus is invalid for a list of size plus size, this dot size. Right? I'm putting it in terms of this list, not in terms of this array that's under the hood. Length 10, I never made anything that was a length 10 over here in the test, right? Do you see anything in here that indicates that there's something of length 10 at all, right? No, there's an empty list, and I'm asking for something that is the 4,001st element, right? So I'm going to throw a new illegal argument exception telling you what the error is in terms of this list, that the size is going to end up being 0, right? Now, out of bounds, how do I test for that? How do I change that from pseudocode into actual code here? All right, well, what about the other end first? I always go left to right? So if it's less than 0, or the index is greater than size. Now let's think about this. 5 things in there, 10, or let's only think about 3 things in there. The size is 3 here. You're asking for elements at 0, 1, and 2. So is it valid to ask for something at index 3? Nope. Greater than, equal to. There we go. All right. Now let's come over here and see what we have. Illegal argument exception, right? So you don't use assert equals. I think you assert throws. And I'm going to have to import this. Add static method from there, I think. All right. And then how do we use it? I forget. Assert throws, throwing. Okay, so illegal argument exception. There. Take that, put it over here, right? And I'm going to take away that, and I'm going to take away the actual here, right? And I need to import it. Nope. Dot class. Is it? There we go. There. That's how you do it. Maybe, maybe not. Assert throw? I thought I imported that already. Okay. Assert throws. Fine. We'll use the Jupyter. Assert throws. There we go. Still not. Okay, I'm going to have to look that one up. Add static. Import for assertions. Nope. Assert. All right, anyway. I'm going to have to do that later on. I'll come back to that later, right? I'm going to have to refresh my memory about how to do this. Right now it'll pass everything because, of course, we're not asserting anything. Actually, it doesn't pass. Oh, because, of course, it's throwing an exception there. That's fine. We can move on. Right? All right. Well, if I did that for the get, what else should I do that for? The add, right? So what would be invalid here? Yeah, is there an invalid index here? Well, there's no index, right? So is there an error condition on this? No, I just want to throw stuff in. Add. All right? So there's no error condition here yet, right? We might come back to this and think about that later on. But as our last thing for today, let's go ahead and say delete, right? So let's go ahead and outline this first of all. All right. 1, actually 0. What's the very first thing I should do? Always be thinking in terms of zero indexing here, right? So what's the very first thing I should do? We do have an index here, right? So let's check for index bounds, right? Then what can we do if we find that that's correct? We know that that thing is there, right? It always helps to whiteboard this stuff. So if you have 10, 20, and 30, and you want to delete, say, 30. Actually, no, let's go ahead and delete 10. Right? What would it look like after that? A blank here, 20 and 30? Do you want that blank there? Nope. So after deleting this, what should it look like? Everything should be shifted down. Right? So I'm going to go ahead and shift all elements down starting at index. ... Okay. All right, that first one should be actually pretty easy. It's going to be initially it's going to be a cut and paste here, but actually be careful here. If there are elements 10, 20, and 30, what are the valid indices here? 0, or what's the size here, first of all? It's going to be 3. Now, what are the valid indices? 0, 1, and 2. Right? So if it's negative, that's invalid. If it's greater than or equal to the size, which is 3, that's also invalid. So we've got that line, which is good. Right? Index as invalid for list of size, same message too, right? There's nothing to change there. Get rid of that because we're done. Right? Shift all elements down starting at index. Ideas on how to do that. If I go 10, 20, 30, 40, and 50, and say that we want to delete, let's go in the middle here, delete 20. What would you do? Would you touch that 10? Nope. Would you touch that 20? Well, I could go ahead and put it, well, first of all, what do I need to do? I need to save it off, right? So now that we're past this, let's say 0.5, save off the value so it can be returned, right? So int result is equal to this dot array sub index. Right? And ultimately, we're going to return the result. Right? But what do I want to do at this 20 here? I want to ignore it. And what do I want to do? I want to take this 30 and move it down here. Right? Then I want to go to the next one. And I want to take this 40 and I want to shift it down here. And then I want to go to 50 and shift it down there. Ideas on how to do that. A for loop, okay. Where would I start? Not at 0, because I already skipped my 10, so index. Right? And while I is less than something, I plus plus. We are going to copy the I plus 1th element to the ith element. And so that is this dot array of I is equal to this dot array of I plus 1. We're taking the I plus 1th element here, and we're shifting it down here. Okay? When do we stop? Now I wish I had been whiteboarding this so that I would have preserved that. 10, 20, 30, 40, 50. We'll go with that. And we wanted 10. We start at the second index here, 1 here, and we end up with 30, 40, 50. Right? Now let's align that with the original. We're going to start here at this index, up here, copying 50 down to 40. Do I go all the way up to this index right here? Nope. So it's going to be this dot size, not the array, but this dot size minus 1. Stop short. Okay? And then semicolon there. All right. That looks good. That looks good. Are we forgetting something? If there were 5 elements in there before, when we delete this one, how many are there now? 4. Are we reflecting that in this code? Nope. So what should we do? This dot size minus minus. Okay? What else aren't we doing that we did? And we can get rid of the cruft there. What else are we not doing that we did up here? We're not shrinking it. Right? So I'm going to put that as a to-do, and we're not actually going to do that, but to-do, consider shrinking this array if the capacity, if the unused capacity exceeds a certain number, right? Number, okay? That's not as useful because usually you're not going to be adding and removing a lot of stuff. Once you add something, right, then you've got this capacity, you might as well use it. The only reason that you'd want to shrink something is if you're using a hell of a lot of memory and now you need to clean up that memory because you don't want to hold on to it by this extra capacity over here, right? All right, we don't have enough time to write the test, but what would the test look like? Public void test delete, right? So create an array with, say, I don't know, 10 elements, right? Delete them one by one. How? Right? How are you going to delete these? Well, I'm going to actually write 3 different tests to do this. I'm going to say, well, if I've got these 5 things, for example, instead of 10, what if I deleted the first one, deleted the first one, deleted the first one, deleted the first one, deleted the first one? Is that the only way that something can be deleted, though? Delete the last one, delete the last one, delete the last one, delete the last one, delete the last one. Right? Interleave, delete the first one, then delete the last one, delete the first one, delete the last one, and I'll leave it like that. Right? Okay? So we're going to test this in various ways. In various ways. I'm probably only going to write one of them, but you should probably think about writing multiple ways. Okay? That's where we'll pick up the design on Wednesday. Right? Okay?